Working with today's high-speed serial data standards means your oscilloscope needs adequate bandwidth to make accurate measurements on those standards. In addition, rise time is yet another critical measurement to determine how much bandwidth you actually need. Some scope vendors want you to believe their limited bandwidth offerings somehow provide measurement results equivalent to or better than Tektronix's high-performance bandwidth models. Let's take a look at a couple of different oscilloscopes to see how they actually perform. Our source of a fast rise time signal is coming from a DSA 8200 sampling scope from Tektronix. This sampling scope's been configured with a fast TDR sampling head. When viewing the output of the sampling head at a bandwidth of 30 GHz, we see that it generates a pulse having an 11 picosecond rise time. Now let's send this signal into a Tektronix DSA 70000 series scope set at 13 GHz. Note that on the measurement captured, we see a 23 picosecond rise time on this pulse's rising edge. When viewing the same pulse on the input to an Agilent 90000 series 13 GHz oscilloscope, we see a rise time measurement of 25 picoseconds, less than the performance of the Tektronix scope at a similar bandwidth setting. But since the Tektronix DSA 70000 series has additional performance, let's move its bandwidth response up to 16 GHz and take a look at that rise time. Now we're seeing a measurement of 19.5 picoseconds. This is a well-characterized signal. Notice how much the extra 3 GHz of bandwidth provides in the form of a faster rise time measurement over and above the 13 GHz scope we just looked at. This is oscilloscope performance you'll need. To further make the point, let's move the bandwidth of the DSA 70000 series all the way up to 20 GHz and make that same rise time measurement. Now we're seeing a measurement result of 16.5 picoseconds. No one comes close to evaluating today's fast serial data signals than Tektronix DSA 70000 series. So just how much bandwidth do you need for accurate measurements on your fast signals? Many serial standards now require test instruments to have performance that captures the fifth harmonic of the fundamental frequency of the signals, the clock frequency. For example, this chart shows that to support PCI Express Gen 2 at 5 gigabits per second, you need 12.5 GHz bandwidth to capture the fifth harmonic. As serial speeds continue to increase, rise time margins become more important to compliance measurements. If your measurement system has insufficient bandwidth to faithfully reproduce the true rise time of your signal, it is possible that your compliance test will produce false measurement results. Tektronix DSA 70000 series is the only oscilloscope on the market with rise time performance that can handle signals for today's emerging standards. When it comes to measuring rise time accurately, 16 GHz or 20 GHz clearly offers more accuracy than Agilent's fastest 13 GHz oscilloscope.